Yes, we are now live. Hi everyone, this is Anisha Suri, and on behalf of Ideas, I welcome you all to this webinar by Brendan, who is a senior data scientist at Metis. Thank you, Brendan, for joining us. And on behalf of Ideas, we welcome you to the webinar.
Oh yeah, thank you guys for having me.
Before we start dwelling into the deep learning for tabular data frameworks, which Brendan is going to talk about, I would briefly like to introduce you all to Ideas. So IDEAS is an international data engineering and science association. It is a non-profit organization which is devoted to bridging the gap between academia and industry in the areas of data science, machine learning, blockchain technologies, and artificial intelligence. So we started in 2016 and we've come a long way, covering different cities of the US at Los Angeles, Chicago, Dallas, and Howard, also New York. And we have organized a couple of events like the data science conferences and blockchain conferences and different hackathons. And we look forward to getting more enthusiasts on board and keep growing. And talking about the blockchain hackathon, we recently, like last month, we had a hackathon in New York, which was for blockchain technology. It was a great success. And this weekend, in fact, we are having a similar kind of hackathon event in Dallas. Without any further ado, Brendan, you can start the talk. Thank you.
Cool, awesome, thanks. Let's go ahead and dive in. Give me just a second while I get my screen share up. And it's a pretty small group. It looks like there's about 20 of us. So if you have any questions, feel free to just shout out in the chat and we'll catch that. You guys have my screen? Cool. So today we're going to be talking about a package that I wrote, Keras-Pandas. In case you're interested in me or anything, you can screenshot this slide. It'll have a link to my blog, to the documentation of the package, and also this set of slides, which are basically exactly the same in that repo. But before we get too far into it, let's talk about the actual package. So you're probably interested a little bit in deep learning and some of the other really awesome technologies that you're hearing about. If you're like I was a couple of years ago, you might be interested in really diving in and starting to use this in your own practice. For example, at that time I was at a very large bank and we were interested in seeing if we could leverage some of these new technologies. You might start that journey by actually just going to the Keras examples directory. Keras is a really popular deep learning framework. And in this directory, you can look through and actually see that there's a whole bunch of different types of examples. For example, we've got computer vision examples, test and sequence, so sequence, neural language translation, generative model examples. This is really awesome, but for most data scientists, your data doesn't really look like this. For most data scientists, your data will actually be numerical variables, categorical variables, date times, things like that. And there's a little bit of a disconnect. A lot of the examples, a lot of the work we're seeing in deep learning particularly focuses around computer vision or text, but that's not the data that a lot of us actually use day to day. There are a lot of techniques for these types of data and for real tabular data. And we're going to dive into that just a little bit. We'll look at this a couple of different ways, first starting with an introduction, then getting to a hands-on example, because I think the proof is really in the pudding here, and having a look at what this package does and how it does it. Then we'll get started looking under the hood and understanding what some of the high-level abstractions look like, or what's actually happening to your data and what the common workflow looks like, and then also dive into getting started, and how best to use the package. Kind of getting started with the intro, the key takeaway here is that deep learning should be attainable. Keras-Pandas allows users to rapidly build on and iterate deep learning models. It's designed really with two user bases in mind. For new users, people who are less familiar with deep learning, it lowers the barrier to entry and provides a really good starting point for kind of getting the feeling out and starting to get your hands on deep learning pipelines and workflows and understanding what common techniques or best practices look like. Again, many of these practices stolen from Kaggle Grandmasters or leaderboards or really deep technical papers. For existing users, it also allows for really rapid iteration. So even if you know exactly the transformations and the kinds of layers and the number of neurons you want, it still allows you to move really, really quickly. To give you an example, setting up 2 or 3 variables, text variables, could take 5 or 10 minutes each. So that's 15 minutes. And if you've got 2 or 3 of them, it's only 15 minutes. But if you've got 20 or 30 variables, you can spend 3 or 4 hours really easily just doing the typing, just connecting the odds and ends. Doing that with my framework takes about 2 or 3 minutes. So it'll get you iterating and changing your variable types and changing your options a lot more quickly by allowing for a much higher level abstraction. I think the proof is really in the pudding. So let's talk about our hands-on experiences and really talk about the old experience versus the new experience, and we'll actually see just a little bit of a demo. So as I mentioned before, the old way of doing things, if you're just using TensorFlow or Keras or PyTorch or any of these frameworks, is very, very highly customizable. You choose your own data transformations, you choose exactly what you want to have happen with your data, the format and the input layers, and actually connecting these input layers, saying, hey, I've got 30 variables with this kind of shape. If you've done any sort of dealing with Keras before, you know the input shape can be a real pain. It takes a lot of time. It takes a lot of decisioning, reading a lot of papers, understanding what the best practices are, what's latest and greatest, which even as NIPS is wrapping up, changes every single year. It's all really heuristic driven. So it involves a high amount of domain expertise, neural network theories, and heuristics. So reading a whole bunch of papers, being very upfront about what the best techniques are. And it's also, and this is unfortunate, really, really repetitive. So it can be time consuming. If you've got 5 or 10 text variables, creating the exact same inputs for all of those variables just takes forever, and it's a real pain. Let's talk about a different format, which is the Keras-Pandas way. I'll go ahead and admit it's less customizable. In the style of Python, it's a batteries included default for every data type. So if you see you've got a bunch of text variables, we'll go ahead and set those up for you. If you've got numerical, categorical, date, time, Boolean, all those things will be handled under the hood and give you state-of-the-art results and state-of-the-art models. It's also really, really rapid because rather than having to build out each of these one by one, we can build it out in a bulk fashion. It's also finally a lot more maintainable. Because we don't have code spaghetti or copy and paste code, there's a much more consistent code base with a lot less redundancy. Also highlight, my entire code base goes through regular unit testing and integration testing. There's a pipeline that sets up to run all the tests every single night. And there's, again, open source, so I've got a lot of eyes on it and people who actually catch minor bugs or have minor feature requests and provide a much higher level of abstraction. And with that said, let's go ahead and dive into a demo. Let's see what this looks like. In this demo, the code is up and available within the repo if you want to check out the Keras-Pandas repo as well. Let me just check really quickly that you guys still have my screen. I think we're still looking good. So just a couple of blocks here. So as I mentioned before, if we had 20 or 30 variables, it might take 2 or 3 hours to just set things up. We're going to do it in the next minute or two. So let's go ahead and start with the imports. Here we've got some stuff just from the standard library, a couple of items from sklearn and from Keras. These are just setup that we need. And these last 2 imports are the 2 imports from Keras-Pandas from the package that we're evaluating. And we'll get into those in just a second. I'm going to load in the lending club data. If you're not familiar with it, we can have a look at it here.
Hey, Brendan.
Yeah.
We don't see the screen yet. It's the desktop we're seeing.
Okay.
Yeah.
Thanks. Let me go ahead and make sure that we still got the screen share. Are you able to see my screen now?
Yeah, this is good. Yeah.
Oh, cool. Thanks for the catch.
Yeah, sure.
So yeah, here we've got our imports, and the 2 items we'll be looking at are just the Keras-Pandas library, which is again pip installable if you want to do a pip install Keras-Pandas. And we're going to load in the lending club data set. The lending club data set is pretty popular. It's a live micro lending or peer-to-peer lending data set. And this is actually historical data that'll give you a whole bunch of information about the loan, about the borrower, and tell you whether the loan basically was paid off or it went into a default. And if we look through it, we can see a whole bunch of fun and interesting information. I'm not going to scroll through the columns too much, but you can see the amount funded, the term, the interest rate that was charged, the number of installments, credit grade, just a whole bunch of very, very fun financial information. It's actually, peer-to-peer lending is an interesting way to make some money. I know some people who invest in this as well. And some of the better ways of getting information out of it just combing through past observations. So let's say that we want to start building a model to determine whether or not this loan will default or be paid off. And the variable there that we're going to look at is loan status. Again, you could build a very, very complex deep learning model, but we're going to start off with just the best practices, just state of the art, according to a couple of recent published papers and the work that's being done on Kaggle. So we've got 3 types of data that were being used here. There's support for a couple of other data types as well. But we've got numerical variables, things like the loan amount, the person's annual income, the number of open accounts, their debt to income ratio, other variables like this. We've got a couple of categorical variables. These are things we'll use entity embeddings for, like the term length, their credit grade, their employment length. The employment length actually isn't given a number of years, but it's sort of bucketed into 0 to 5, 6 to 10, things like that. Home ownership, which is actually really a Boolean, but we're going to treat that as a categorical, and other items like that. You'll notice that I'm including loan status here. That's not because we're having any sort of data sneak in. It's just so that the model knows how to format the data correctly. So if we're creating a model to predict the loan status, good or bad, basically default or not, it'll know to create 2 output variables. From there, we can create our automator. The automator is really the crux of what's going on here, the crux of what's going to help us out. And the automator is just going to accept this data type dict. And this is how we communicate to the model that we'd like certain variables handled in a certain way. In a future release, I like to automate this. So if you just give a list of variables, I'll determine the data type for you. Not quite there yet. It'll also highlight which variable we want to predict. This variable, of course, will be withheld. So we're not going to let it sneak into the input data set, anything like that. And this automator in and of itself is an sklearn compliant transformer. So if you wanted to use part of a larger pipeline, you could, but it's going to be the same sklearn interface that you're probably familiar with. So we're going to do a .fit and fit on the train observations that we split out earlier. And this will help the automator to realize for the categorical variables, how many different levels there are, how to treat each of them. For the numerical variables, if we're imputing, how we're going to impute, or if we're going to z-score normalize or whiten, basically what the mean, the standard deviation looks like, all of these fun kinds of things. This will happen statefully. So if we wanted to save the automator, use this in a future pipeline, we totally could, totally repackageable. Then we're going to transform our data. We're going to transform our train and test data separately, though we could do it at the same time. And again, this will do everything possible to avoid leakage. If you wanted to, you can actually drop the response variable from the test data set, and you'll just get none back in your y variable. So for example, if you're using this with a Kaggle data set, you don't actually have the test response variable. All of that formatting will happen under the hood. Again, this is all happening to prevent any form of leakage. Let's go ahead and run these cells as well. Just informing the automator of what the data types are like, doing a train test split, and as any good data scientist should. And then I'll also highlight here, when we do the transform, we can either return back a pandas data frame, or we can return back the X and Y that sklearn or Keras is expecting. Here I'm going to give the Keras format instead. And then here comes the fun stuff. We're actually going to create a deep learning model. Again, this could take hours if you're doing it by hand, but it's really, really simple. The automator is going to give us an input nub. This nub is correctly formatted to accept all the correct input shapes for all of the different variables we have. It's actually a multi-input model, which can be very, very tricky. Those are all connected with a cat layer right at the very end. Just setting up this input nub is like the bane of most data scientists' existence. It's a very, very high barrier to entry because it takes a whole lot of time. And here we're doing it automatically. It's just a one-liner. It's not a very interesting model. So we're just going to build 2 dense 32 neuron layers. And then we're also going to have an output nub. And this output nub is aware of the format that we're trying to predict. We're trying to predict a categorical variable with really 2 layers. So it's going to create 3 neurons with the softmax. The 3rd neuron is going to be for an unknown layer, just in case we see anything that's really, really unusual. From there, we can create our Keras model. And then this Keras model, again, is just an sklearn estimator. So if we wanted to put in a pipeline, we definitely could. We're going to compile the model. Right now, we're going to use the Atom optimizer. Pretty much the latest and greatest. This is a pretty good default unless you're doing recurrent neural networks, in which case there's something else that you'll use. And then also, because picking a loss can be a little bit difficult, the automator is going to suggest a loss for us. We can fit our model here, and then also perform a transform. Because training the model will take just a second because there's a fair number of neurons, and And then because we're doing the prediction in kind of a strange space, because we're going to predict basically 3 different numbers and we'll have to do the max probability against all of them, we can do an inverse transform. And here it's actually predicting the third, which is going to be that it's, I believe, a good loan. This isn't a really, really highly predictive model. You probably need to change the hidden layers just a little bit, but it allows you to really, really quickly get all of your data in and start playing with those hidden layers and start playing with the data that you will or will not include with a model. I've only trained one model with a very small data set, which is why we're seeing pretty uniform outputs. That's just so that we can get this done over the course of the demo. Let me go ahead and switch back to the slide deck. And while I'm doing that, do you know if there's any questions in the chat? Cool. Let's go ahead and dive in. Now that we've seen this demo that allows us to very, very rapidly get deep learning models up and running and look at what's going under the hood. And we'll move through this pretty quickly, just in the interest of time. So every data type really has 3 kinds of handlers. There's transformations. These are the ways that we actually transform the data. And we'll see a couple examples in a second. Things like processing and formatting the data. There's the input layers that correctly accept the formatted data. So actually getting your data into Keras or into a lot of deep learning platforms can be a real pain. So I do that automatically. There's the output layers and laws. So any data type that supports output layers or supports being used as an output, such as numerical or categorical, you need to know how to correctly format that output layer and also probably what loss you want to use. To make it a little bit more concrete, we can look at numerical variables. So for numerical variables, if we have data coming in, we're going to impute it. We'll do null filling. Here we'll do median null filling, which is pretty state-of-the-art, pretty common, so that our model can accept it and not have to break anytime there's a null. And then we'll also do standard scalar, which is a form of normalization or whitening. Here we're going to use Gaussian normalization. This is a step who a lot of people who are new to deep learning will skip, but it'll really, really improve our results because then our model doesn't need to know the scale of our data. It just needs to know the variance that's within. The input layer is going to be a standard input layer with just 1 neuron, and the output layer is just a single neuron with a loss of probably a mean squared error for most cases. Slightly more interesting example is the categorical example. This is a little bit more difficult, a little bit newer, but we're going to use an entity embedding here. And the categorical imputer is a pretty custom layer that does null filling. And basically, if you have a null value, we're going to say either, depending on the data set, it's like the most common level that we have. So if you have apple, banana, and kiwi, if there's a lot of apples and you see a null, you're just going to fill in the apple. Or, and this is a slightly more powerful technique, if it's apple, banana, and kiwi and we see a null, we'll say other. We'll actually give it an other bucket, which will help us to understand that for some reason it wasn't caught correctly. And then we'll put it into a label encoder, and this will transform it strictly so that Keras can accept it. Getting that label to handle correctly is a little bit difficult, but it's going to happen under the hood for you. Then the input layers, this is where some of the magic is happening. So we're going to have an input layer. We're going to do an embedding layer, which is an entity embedding, pretty similar to Word2Vec, but with much smaller number of levels. Then also flatten it so we can feed it in. And then if you're doing an output with categorical variables, for those of you who are familiar, it'll be just 1 neuron per categorical level. And the loss here will be probably categorical cross entropy. There's a couple of other additional data types that we have support for now. So numerical, categorical data we've seen already, binary, which is just a special case of categorical, and text data. Text is really, really difficult to get into Keras. Something that might be changing in TensorFlow 2.0. But for right now, it takes a lot of formatting, particularly if you want to use pre-trained weights. A couple of other data types that are coming soon, and these are coming up at about 1 every 2 weeks. Support for time series data, and this is just about to get the final release. But if you have any sort of stock data or financial data, time series is one of the most commonly requested asks. There's also timestamps. So if you have a whole bunch of timestamps in your data set, but it's only 1 timestamp per observation, there's a couple of really, really awesome techniques around sine, cosine decomposition and FFTs that can get us pretty far. And then also support for rolling your own pipelines. If you want to create your own data type, your own transformers, there's technically support for that now, but it's not very heavily documented. Wrapping it all up, bringing it all together, and if you're interested in getting started, there's a couple of places to look. The best place to go is probably the example and the README. So if you read the documentations, there's a quick README to kind of get you into the format. A lot of people who will email me and ask for help, I just send them there, and they're able to get going pretty quickly. A couple of folks, actually at Google, and a couple of hedge fund folks have found a lot of help out of this in the examples folder. There's also the docs. It's near total coverage and it dives deeper than this, but there's a Read the Docs website that goes into how everything's formatted, how you can contribute. The README goes into how to use it, and then also getting involved. So I'm pretty actively looking for collaborators who want to write code and feedback as well. I'm getting about 1 or 2 issues a week. Sometimes people just email me with their asks because they don't want to be affiliated with their public GitHub because of company restraints or privacy restraints like that. But feel free to reach out. There's a couple people, again, large and small companies using this already, and it's growing a very, very interesting community. It's always fun to get feedback about how things work for your use cases. But again, if you really, really want to get involved, just check out Keras-Pandas.readthedocs.io. This documentation is being kept up to date. It's released with every new release, and it's auto-compiled, which is really nice. It dives just a little bit deeper than I can in this talk. In case you're interested, there's a couple of next steps for the project. There's support for time series, which is actually built in just in the final steps of getting a release. So anytime you have multiple time steps for an observation, like the user's past transactions, or the past checkouts for a book, or user profiles for the past people who've looked at a particular item, this is coming pretty rapidly. Timestamps will be coming up probably in a week or so. I'm just iterating and getting more and more examples up there. That's actually probably my biggest ask is there's an interesting data set that you're using. Unfortunately, a lot of example data sets are really, really easy to deal with. That's not what I want. The point here is to see real live data. With that, I'll say thank you, and I'll leave this up for just a moment if you want to take a screenshot. This link will point you towards my personal website with my blog and some of the things that I've worked on, and also the documentation. Additionally, these slides are available at the Google link here. And with that, I'll say thanks, and I think we've got just a little bit of time to open it up for questions. So thank you, guys.
Thank you, Brendan. We are waiting on for questions. Let's give a few minutes for people to type or something, a few seconds.
Absolutely.
Feel free to shoot any questions, guys.
Cool. Well, that's formulating. I'll also highlight, I think there's been 2 unique joys in getting this package together. The first is actually just kind of getting to write it and getting to write a package, which has been a really fun journey, a little bit different than I thought it would be like. And then also, as I've gotten a couple of things from the people who actually are working on Keras at Google and a couple of hedge fund guys. And it's just fun to see people actually using it. It's fun to see examples of people who, would otherwise be spending a ton of time building out very, very similar functionality, who are able to take it just off the shelf and give their very, very honest feedback about it and get it working, in some cases, even in production. Doesn't look like we have...
There's one comment from Carl Mullins. He wants to say thank you to you.
Oh.
And actually, I have a question. So did you build this up from scratch, or have you been using some available libraries from TensorFlow or as a model? How does that work?
Yeah, that's a great question. So there's 3 different layers. The core layer is TensorFlow, which is really the compute engine behind this. There's a lot of great work that's gone into making TensorFlow run on GPU and TPU and be very, very distributable. Keras is a higher level abstraction. Keras allows you to think about kind of bigger concepts and work a little bit more quickly, then I sit on top of both. I sit on top of Keras, usually using the TensorFlow backend, and allow for pretty drag and drop. So if you wanted to use any TensorFlow or Keras component inside of this or in addition to this, you totally could. But by default, it's a very high level API, and then you can get into the lower level APIs whenever you'd like.
Oh, okay, thank you.
Yeah, I think I see one question. So yeah, if you wanted to use a GPU backend, this is being powered by TensorFlow. So that's actually my most common MO is I'll usually prototype things on my laptop just because it's a little bit easier. But then once I get into an actual Kaggle competition or into a bigger data set, I'll export the model or I'll just export the code and I'll run it usually on an EC2 instance on AWS and train it on a GPU as well. So all of this has full support with GPU all through TensorFlow and Keras. Awesome. Well, if there's no more questions, it's been fun chatting with you guys. I hope you enjoy your Sunday or Monday, depending where you're at. And Anisha, anything else from you?
I think that's pretty much it. I also had like a question. It's not directly related to the library in particular, but with deep learning in general.
Yeah.
I was trying to understand how it works actually. It looks like something magical. I mean, like with the other algorithms which have a fundamental, mathematics associated with them, like any example, like decision tree or random forest or anything. But with deep learning, you just have neurons and layers. I was just trying to put things together, and how is that it gives like such good results as compared to the other. Yeah.
So at its core, it's all just an ensemble. It's all many neurons, which are basically just OLS, just standard linear regression as we all know it. But by having many estimators make many small decisions, you can actually sort of bootstrap them up and train them all together. Particularly given a lot of data, you have a lot of free parameters, but you can train each of these small estimators to create a huge ensemble that can have really, really strong predictive results. You can also get, one of the interesting bits is nonlinearity. So by using a nonlinear activation, you can get really, really amazing results because it turns out that a lot of domains actually do have nonlinear relationships, and that's another huge strength.
Okay. Thank you, Brendan. That answers a couple of things. Yeah. And to all the attendees, there is a poll that is there, like a short poll to see where you got to know about this webinar and how you liked it. So we want you to just like take a few seconds to answer it. And if you have any other questions, you can reach out to Brendan directly as he shared his details with you. And I think that's all from Ideas today. Yeah. Thank you, Brendan. Thank you so much.
Thank you, guys. Have a good day. Bye.
Bye-bye.